let's take a look at this full wave bridge rectifier. We're supposed to find this time voltage peak across the load, average voltage, peak current, average current, and PIV. I'm going to start solving this problem from the power source, my primary voltage, because I do not have any other currents given over here. That's why I'm going to start from primary voltage. Because my voltage is given in RMS, I'm going to convert RMS to peak. Remember, the general formula for RMS voltage says V RMS is equal voltage peak times 0.707. In order to find voltage peak, I have to divide both sides equation of this formula by 0.707. 0.707 and 0.707 will cancel out, and I have voltage peak is equal V RMS over 0.707. Because I'm looking for the primary voltage, I'm going to write over here my primary voltage peak, and primary RMS has to be converted to voltage peak. That's why I wrote 1 over here. This is equal to 120 volts over 0.707. 120 divided by 0.707 is 169.73 volts. This is my primary peak voltage. Next, I'm going to calculate the secondary voltage. Secondary voltage is between these two terminals of my transformer, V2. I'm going to use the transformer formula. V2 over V1 equals N2 over N1. I have to find V2, I have to solve the proportion. Cross multiply, and I'm going to have V2 times N1 equals V1 times N2. I'm looking for V2, that's why I have to divide both sides equation by N1. N1 and N1 will cancel out, and I have V2 equals V1 N2 over N1, where V1 is equal, of course, peak. I'm looking for peak, V2 peak. I have to use over here peak value also. V1 peak is 169.73 volts times N2. This is my N2. This is my N1. N2 is equal 1 again, and I have N1, which is equal 8. This is going to be equal V2 peak 21.21 volts. This is my secondary voltage. Next, I'm supposed to find VL peak. VL peak is the voltage peak across resistor RL. Please notice that this time current is going to go by 2 diodes when half a cycle, when positive half a cycle is going to come to either these 2 terminals. Anytime I'm going to have positive half a cycle at the top terminal, I'm going to have negative at the bottom. So my current is going to go in this direction. When positive half a cycle is appearing over here, I'm going to have this diode conducting, because positive goes to positive, will forward bias this diode. So current will go like this. Okay, and I'm going to have another anode over here. So as you can see, 2 diodes are going to work at the same time. When negative half a cycle is going to appear at this terminal, this diode is going to be reverse biased. This terminal will take over. So I'm going to have positive half a cycle going through this point, and at this moment I'm going to forward bias this diode. The current is going to go by the resistor will go back to this point and will forward bias this diode and will go back to the transformer. So when I have positive half a cycle at this point, these two diodes are conducting. When I'm going to have negative half a cycle at the top and positive at the bottom, these two diodes are going to conduct. So always two diodes are going to conduct. That's why in order to find the VL peak, I'm going to subtract from V secondary peak minus 2 VDs, because each diode is going to drop 0.7 volts. V2 peak is 21.21 volts minus 2 times 0.7, which is equal VL peak 19.81 volts. This is voltage across the resistor. Remember, when we talk about the bridge, two diodes are always conducting. That's why I'm subtracting 2 VD. This is my VL peak. Next, I have to find VL average. VL average has the formula, which is also VDC, has the formula which says VL peak times 0.637. VL peak times 0.637, and this is equal VL peak 19.81 volts times 0.637 equals VL average is 12.61 volts. This is my DC voltage across the resistor. Next, we're supposed to find IL peak. IL peak we are going to find by using Ohm's law. VL peak is nothing else just VL peak over RL. So this is equal VL peak, which is equal 19.81 volts, 19.81 volts, divided by RL, which is equal 470 ohms. I have to add over here, 470 ohms. And this is equal 19.81 divided by 470 gives me 42.14 milliamps. This is my IL peak. Next, we're supposed to find IL average. IL average you can find by using Ohm's law, which is VL average over RL. VL average we've found, and is equal 12.61 volts over RL, which is equal 470 ohms. This is equal 26.83 milliamps. This is my IL average or IDC. Next we have to find PIV, which is peak inverse voltage, and the formula for it is V secondary peak minus VD, which is equal V secondary peak 21.21 volts minus 0.7 volts, because I'm using silicon diodes. Most of the time in electronics you are going to use silicon diodes, and this is going to be equal 20.51 volts. This is my PIV. If you want to find output frequency, F out is equal 2 times F in. Again, someone is going to ask why. If you are going to look at the oscilloscope and you are going to compare the secondary voltage and your load voltage, you are going to have waves looking like these two. Okay, this is my secondary voltage, which has voltage peak 21.21. This is negative 21.21. This is my voltage. This is my time in seconds. And VL peak we've found is equal 19.81. Now, if you are going to compare the periods, you will see that the period of your secondary voltage is twice longer than the period of your output voltage. It makes the output voltage faster, twice faster than the frequency of the input voltage to the rectifier. I mean, in this case, secondary voltage, okay? So it makes the output voltage having frequency twice of the secondary voltage. That's why my F out is 2 times F in, and this is equal 120 Hertz. And these are the solutions to my problem.